Okay, hello everyone. My name is Ahmed Muthanna from University Putra, Malaysia. I'm Master of Communication Engineering student. Today, I will present about our research, which is deep learning detection of biometric presentation attack. In this presentation, I will cover all this content. First of all, I need to identify what is biometric. Biometrics are physical or behavioral human characteristics which can be used to digitally identify a person to grant access to the systems, devices, or data. Basically, there are two types of biometrics, which are physiological, such as fingerprints, facial patterns, hand, iris, and DNA. Also, secondly, we have behavioral, which are keystroke, signature, and voice. We can see in the paragraph the physiological and behavioral biometric traits. Going to clarify a basic idea of biometric systems. It's starting from the user when is identify himself in front of sensors or cameras, and then going to data acquisition, or after that we're going to extract the features and compare it with our database which recorded previously, and the results will be if matches the features, matches the features with the database that's recorded in previous time. If matches will be identified or verified. If not matched, will be not identified. According to latest survey from Spiceworks company in United States, using of biometric authentication on business technologies, using in different devices such as smartphones, laptops, tablets, and time clock systems, also door locks, application with sensitive data, desktop wearable devices, emails, and point of sales devices and others. It has a huge using in the markets in the world. Also, the planning in the future will be have an increased in using of biometric authentications. Now I will go to identify the face recognition. The face recognition is a process of identifying or verifying the identity of person using their faces. The process includes capture and analyze and compare the patterns based on person facial details. The spoofing happening as a gap for the facial recognition. The spoofing happened, it's like just attack happened where photograph or video or mask of a valid user is presented in front of face recognition system to cheat the system and gain access to data or whatever. One of the dangerous attack is replay video attack, which is trying to spoof the biometric system. The video presentation attack represented replaying video from a digital screen or digital device instead of real person to cheat the biometric system. This is some example of video attack scenario and spoofing. The profile statement of our research, as I mentioned, the face recognition face different types of spoofing attack. One of this attack is replay face video on digital device such as phone, tablet, or any digital screens. Secondly, research on using deep learning in detection video presentation attack by frames are limited. Thirdly, existing methods took a little bit long time to detect the video attack because more frames, more time needs. There is no information about the ideal number of frames should be used to get sufficient results in video presentation attack detection. The aim of our research is to find the ideal number of frames should be used to make face liveness detection, and the objectives identified to achieve this aim. The first one is to design an effective classifier by using learning algorithms. Secondly, to investigate about the optimal number of frames should be used from videos to get best results. Thirdly, to evaluate the performance of the new system of detection in terms of its accuracy and time of detection. Lastly, to improve the effectiveness of detection and achieve high accuracy in results. The project scope of our research is to detection of videos attack by using deep learning, as I mentioned, and extract frames from videos to use a static approach and make face liveness detection. The database utilized in this research was Replay Attack database, which is a popular database used in different biometric research from Switzerland. As literature targeted in our research that using deep learning and dealing with frames, there are two as our target in our targeting. First one, which is enhancing computer vision to detect face spoofing attack using a single frame from play attack using deep learning. And second one, enhanced deep learning architecture for face liveness detection for static and video sequence by using 20 frames. The methodology of our research. Here I can show you the flowchart of our methodology. As I mentioned about the videos that we get it from the play attack database and then extract frames from videos. And after that, going to data pre-processing by using ResNet 50 and evaluate of results. If majority of frames matches the real characteristic, the results will be real face. If matches spoof characteristic, will be spoof face. The system of face liveness detection of our research can show in here also in this paragraph. We are dealing for different number of frames because we as I mentioned, the objective to investigate to find the ideal number of frames. So we started from 3 frames and 5 frames until 7 frames. As we can see here, the input video and then extract the frames and go to the pre-processing. And if the results match, will be real characteristic. If match spoof characteristic, will be spoof face. The replay attack database that we use in our research, as I mentioned, consists of 1,300 video clips of photos and video attacks. Attempts from 50 clients under different light conditions produced at IDMAP Research Institute in Switzerland. Here we can see some example of the database of real and spoof attack. We're targeting the mobile attack phase because, as I mentioned, the database consists of different scenarios. You can see here the real and spoofing attack from the real database. Now going to the distribution of database that we used in our research. We organized our data and extract, as I mentioned, the mobile scenario. the data used and divided in three phases, which is training data and validation data and testing data. The training data is for training our model. The validation data is for monitoring model performance. The testing sets is to evaluate our final model performance to our methodology. Here we can see the distribution of the image that we use. We created three classifiers. The total number of frames we used is more than 1,000 frames, because in deep learning, more data will give you more good or high accuracy in results. So here is the distribution of data in each classifier: training set, validation set, and testing set. The algorithm used in our research is ResNet, or Deep Residual Network. ResNet is a classic neural network used as a backbone for many computer vision tasks. Deep Residual was increasing most groundbreaking work in the computer vision and deep learning community used. ResNet makes possible to train up to 100 or even 1,000 of layers and still achieving compelling good performance. ResNet enhanced the performance of many computer vision applications other than image classification have been boosted, such as objective detection and face recognition. Also, I have to mention that ResNet 50 solved the vanishing ingredients and computer problem in computer vision, which means that's when the not sure if the deep learning or algorithm, if it's deeper, will give good results. So the technique used in ResNet is skip connections instead of going to deeper. So the ResNet 50 solved the vanish ingredient problem in deep learning algorithms. Here we can see the ResNet architecture as proposed in the publisher. Sorry. Our results, now going to our result, the results of classifier 1. We can see our model for the first classifier is in model accuracy is very good, and showing is a good fit, and the model loss, the training or sorry, and model accuracy in our training and validation set, we can see our results, which is 1, which is very good as a result. And going to the model loss, the training and validation curves shows good fit for the first classifier. And in terms of testing, we can see here the accuracy of first classifier taken from the frames, from different frames that the model didn't see before, just training and validating and testing about it. And going to the results of second classifiers, also, sorry, we can see the model accuracy for training validation set for the second classifier, which is 1, also very good. And in terms of model loss, the training validation show a good fit also, which is not underfitting and not overfitting. Also, this is the testing for the second classifiers. We can see the accuracy results. Also here, the results for the third classifier. As I mentioned, for results analysis for using 3, 5, 7 frames for detection, because we investigate to find the ideal number of frames. So after we took 3 frames, we can see the accuracy for each videos, or we cover all the 50 clients in the apply attack database. You can see here our results for 3 frames is 96.93, 100%. And the accuracy results for using 5 frames, which is 96.53, 100%, and also 96 for 100% for 7 frames. As we can see here, the higher results, we got it from 3 frames, which is here. So no need to going for more than. And also we make comparison of our results with other research, which is, we can see here our model, ResNet 50. Here is our accuracy and the inception version for the literature that we are targeted. We get higher than result. Here they use single frames. And here they use 20 frames. As we know, more frames need more time for detection. So here, when we use 3 frames, we achieve high accuracy comparing with using single frame and less time. And instead of going to 20 frames, we can see here our results. It's very good comparing with going to CNN LSTM for 20 frames in terms of time. In conclusion, our classifier we created was able to classify the real or spoof person. From our results we obtained, we found that the 3 frames is ideal number of frames for make face likeness detection. The performance of our system, we found that accuracy is high and less time of detection with using 3 frames. There is this 50 classifier gave us a high accuracy, 96.993, 100% by using 3 frames. We also noticed that the using of 5 on 7 frames for detection in our system decreased the accuracy and increased the time of detection. That's all. Thank you so much.